this session, we are going to see how to optimize a model for performance in Power BI. That is, what are the best practices and ways to enhance the performance in Power BI. So, there are three modules. One is semantic model optimization, performance review using performance analyzer, and how to use variables in DAX to leverage the performance. So this is the agenda. Why performance matters in Power BI. And first module is semantic model optimization. Second one is reviewing performance of measures and visuals using performance analyzer. Third is variable syntax. Last is the checklist performance optimization checklist. So why performance matters in Power BI? Slower reports destroy user trust and adoption rates. When it comes to a big organization, there will be huge data containing millions of rows. So for each interaction, at the back end, the data source and Vertipack engine process many things. So we need to take care of this performance optimization with highest priority. As I said, every click and every slicer and filter triggers and every interaction DAX query for every visual, it consumes a processing time. So we need to take care of the performance. A large data set is equal to millions of rows evaluated on every refresh. And lastly, performance is a model design problem, not a hardware problem. So, uh, how good is your model design? Uh, that decides the performance of your report. And these are the common culprits. Bloated tables with the unused columns. We need to remove unnecessary columns which you are not utilizing in the report. Wrong data types. The integer data type can be compressed easily by Vertipack engine. So we need to avoid using text IDs wherever possible. And inefficient tags. You need to leverage the usage of variables instead of repeating the logic, which we will see in upcoming slides. Too many visuals on a single page. We need to use what the visuals which we need uh, only. So we should not have a data first thinking. We need to have a message first thinking. That is, we should not dump the data by showing many visuals in our report. We need to use optimum level of visuals which delivers the message clearly. Second is bidirectional relationships, which we will see in upcoming session. If you use single direction, it propagates only one time. But if you use bidirectional between two tables, it doubles the time. So we need to avoid using that. Auto datetime enabled on all date columns. So by default, Power BI enables date columns in the model which are available in the model. So we need to disable that, and most of the organization the inbuilt dimension table will be developed in the source itself. So we need to use that and also disable this one, flat tables instead of star schema. Star schema approach we need to follow, where centrally we will keep the fact table, and around that we need to have dimension table. We should not have all the data in a single table, and also with unnecessary columns, which affects the compressibility and also affects the performance. So this is the module, semantic model optimization techniques. So these are the main things we need to take care of. As we have seen earlier, remove unused columns and rows, choose correct data types, understand cardinality, unique values should be taken care of. For example, in a datetime column, we need to go with the date instead of date and time data type. And also, if there is a information related to date, time, uh, where you have up to microsecond level of data, you need to check whether that data is needed to show in report. If that is not needed, you can restrict only up to date and remove that, which increases the performance to a greater extent. And star schema versus flat table, this is a very important design choice. We need to go with star schema, and also other thing, one more thing, we need to avoid using snowflake schema, which affects the performance where and, because the tax relationship should propagate more number of tables, and it increases the complexity of joins, thus affects the performance time. And lastly, import mode versus direct query mode. Uh, as we have seen, import mode increases the performance because all the data it is imported into the memory engine itself. So the processing time will be higher than the direct query. That also we will see in upcoming slide. Remove unused columns and rows. So only load columns you use in visuals and filters or DAX measures. Filter source at the source in Power Query, never in DAX. So we need to filter the rows in Power Query itself. We need to remove the unwanted rows. We should not treat like okay we can deal in DAX like that. And every unused column consumes memory even if never referenced. Yeah, this is why we need to remove the unused columns. Text columns have high cardinality. So for this only we need to use integer data type wherever possible for customer IDs, product IDs, and all. And never import a column just in case I might need it later. So it's you should not treat a memory engine like just a hard disk for storage. It deals with all the processing RB report. So if you don't need a column, you just remove it. That's the good thing to do. And second thing, if you see the 30 to 50% of model size reduction by removing just 5 unused columns. So the first two performance boost is this one, remove unused columns and rows. So because it leverages our performance up to 30 to 50%. So we need to take care of them as the highest priority. Second thing, data types, coordinate and star schema. Data types, you can see the order. Integer has the best compressibility, so then decimal, then text. So wherever possible we need to go with integer and decimal data type. Only for string data which can be useful for deriving insights in the report, then for that cases we need to go with text data type and cardinality. For example, like in date and date time column will be a good example. If you use date and time, then the cardinality will be high. There will be so many unique values. So in that case, if that time level granularity is not needed, then we can just remove that part and we can use just the date. Thus, it improves the cardinality and improves the performance. Last thing, star schema. This important design choice. You need to have a single direction tables which is from dimension to fact, that it should not be both direction. And dimension table usually will be smaller, and large fact table where the transaction level data is available. And flat tables should be avoided. You should not dump all the columns in a single table. It also affects the compressibility of the packaging. Next, auto datetime and import as direct query feature. So by default, Power Query creates a date table for every date column in your. Uh, but in most of the organization, the date table will be already created in the Power Query itself, or in the data source itself. Date table will be available. We need to use that instead of using this auto datetime feature, which will increase the performance to a greater extent. And second thing is import mode. Wherever possible, we need to use import mode because data is cached in the multipack memory itself, and it is ultra fast query engine, and it can compress the columns effectively, and it works offline. So the only advantage which direct query offers is the data refreshness. It gives the data refreshness weekly, and the data is in sync with the source itself. Uh, but when it comes to performance, we need to go with import mode. And also the disadvantage in direct query is limited DAX functions. So that is also one disadvantages. So based on the requirement, we need to choose. But if performance is the primary thing, then we need to go with input mode. So these are the points I summarized from this module. So we will see an example for showing the semantic model optimization. So here, if you see in dimension customer table, we have two columns where duplicate columns is there. This the only one column we can have, and other columns we can remove because unused column should be removed. Both give represents the same unique customer IDs. This customer key we can remove. Similar to date key is not useful. Mostly date columns will have date, year, month, and quarter. Date key will not be useful in report. This also we can remove. And thirdly, the product key. So here, if let's say if you are using product ID, then we can remove product key column. And also, if you notice it is in text data type, here this one we need to change the integer data type. Thus, leveraging the compressibility factor. Territory column seems to be fine. And the fact sets here also, if you see, it is in text data type. This one we need to convert change type to um, whole number. Okay, so actually this is okay. Yeah, here we need to deal with the content itself, because here you can see for notation they have prefixed with C. First we need to remove this C from this columns values. Then we need to convert the data type to integer data type. The same for product ID also. Then the relationship can be established in a better manner. Now in factory you can see this product description, customer phone number, email, and orders. So these are trivial information which is particular to that specific transaction. From this we can't derive any useful insight uh, when building reports. So these rows we can remove. Second thing is, I'll show you the auto date time feature where we need to disable. So this one now I enable it is in enabled mode. Before building any report, you can disable this one. Yeah. So I will show you the optimized model. So this model, if you see, I optimized this one. I changed the customer ID to correct data type, and also I remove the unnecessary columns. If you see here also, I removed the unnecessary customer key and kept only customer ID, that it is the redundant data. I removed the column, and also product ID. So then we will move to next slide. Review performance of measures or relationship and visuals using performance analysis. So to measure the performance and debug the performance in Power BI, we have two tools. One is performance analyzer, which is built-in tool of Power BI. Second one is DAX Studio. It's an external tool, but if you want to debug further, then we need to go with DAX Studio. By copying the DAX query code from performance analyzer, we can debug the query in DAX Studio. Measure query time analysis. This query time measure can be seen in performance analysis and relationship direction impact. So as we have seen previously, the direction of relationship should be in single direction, and it is the default in Power BI. Unless or otherwise, if you change it to both, it will be in single direction. So performance analyzer too. So what are the metrics it measures per visual? Task query time, visual display time, and other. Task query time, it is a primary uh, metric among these three. So time, what is the time taking for evaluating the measure? It shows that time, and visual display time. So how much data it takes to process the measure and to interact the data by processing the measure and display it in the visual. That it represents the time, and the other represents the metadata and overhead data which is generated by the engine itself. Now we'll see the performance analyzer in practice with a small example. So before using performance analyzer, we need to clear the cache, because if we have a cache and if you're not clearing, then it will give wrong calculation of times. Yeah. Now I am calculating this according to the visual. You can see it's about 611, task by 450 milliseconds. Stopping. Okay, this one. I'm going to check the fast report. Clearing the cache. Text again. Starting the recording. Yeah. Now you can see the time is drastically reduced to 130 millisecond. So why there is this difference? You can see the measure. The data which I used in both the uh, visual, it is same data like rows and columns, and fields are same. Only difference is the values it shows showing also same, but only the how measure is processing, only that difference is there. I will show you this measure. So here I didn't use any variable. I referenced every column more than once, and also use iterator function here, which process row wise. When you compare with this faster one, here I have used variable. So the if you use variable, it will execute only once, and that stored value will be used down the order in the same measure. And also other thing is I have used sum, which is simple aggregation function, which performs better than summax in terms of uh, time consumption, because summax performs row wise, but sum aggregates the data at a single shot. Then at last I returned the output. So this increases the performance. So that's why you are seeing the time difference between the both reports. And also one more thing is, like, I have just used the shown you the task query. If you are using multiple pages in a report and multiple visual, then that interaction also recorded in the visual display section. That also you need to take care of. Next slide. Relationship performance. So as we have discussed earlier, we need to have a single direction relationship between a dimension and fact table. If filters flows both the direction, then it will increase the timing and thus affects the performance. So Vertify handles it efficiently because the filter is propagating in single direction. So the performance will be good. If you use both direction, then both the direction the Vertify should uh, function, thus affecting the performance. No ambiguity or circular dependency. What it means is, let's say if you have two tables and there are two relationships between the tables, it is circular dependency and it ambiguity will occur. It is avoided in single direction relationship. It can cause circular dependency errors and ambiguity in case of bidirection. Power BI defaults this relationship between fact table and dimension table, or between any dimension table to dimension table. Only if it is a one-to-one relationship, there it will be both direction, but one-to-one relationship is not preferable in model view. You need to optimize your model view to have a one-to-many relationship. It's significantly slower. Yes, bidirectional significantly slower. And if you want to use bidirection, then you need not to change in the model view the direction of the relationship. You can use the cross filter for the specific visual where you want to use the bidirectional relationship. So uh, the another thing is there the inside the Vetipack engine there is two types of engine. One is storage engine and formula engine. Wherever if you are able to use storage engine and you need to use those kind of DAX queries, and wherever possible to use formula engine, only the specific scenarios if needed we need to go with the formula engine DAX queries. For example, before that we will see the advantages. It reads compressed Vetipack data and highly parallelized. Simultaneously, multiple processing will be done and creates a data catch result set and its aggregations natively. On the other hand, interprets complex tax logic. So when there is a nested logic, it will be complex, and to process that it will take time, and thus increasing the time consumption and affecting the performance. So only if storage engine is not able to take care, in that case formula engine process the data. That's how internally Vetipack works. So most of the time you need to leverage the usage of storage engine. Formula engine handles the complex context transition. So that's why when you see this example, the most of the iterated functions row level and context transition happens in that iterated function. So that's why formula engine comes into that's where formula engine comes into picture. But basic aggregation function, simple calculate and implicit filter uses storage engine, and basic relationship travel set done by storage engine. So wherever possible, we need to use storage. We need to use storage engine friendly tax measures. The last model, what we are going to see is usage of variables to improve performance and troubleshooting. So we should need to use var keyword wherever possible. Like when we are using single in a single measure, if you are using multiple expression and if you are repeating that expression, then it is not advisable. We need to use a var keyword there, and we can also can do step by step debugging with the written statement. So the readability also high, and the error is also it is easily identified. And variable stores scalars and tables both. So it stores a constant value which can be used down the order when evaluating the final output. And also it gives one more advantage is it helps us to avoid using earlier function which uses outer filter context, and it reduces the readability, the earlier function, but variables increase the readability and also increase the performance. These are some of the measures, example for a measure with the variables. Here I have given just a simple measure where the sum expression is used more than once, but when it comes to large number of measures in many pages and many visuals, it plays an important role in improving performance. these variables. So those are the points I have mentioned here. Engine evaluates separately each time. This is the problem. And since it summates evaluate thousands of times. So here we have used just sum, but let's imagine if you are using summates in process row by row, and if there are millions of rows, then it will drastically affect the performance. Yeah. So see here I have used a variable. Here it evaluates only one time, and down the order it is used that stored value and gives the output. And we can also debug instantly, and it is readability, and it is evaluated only once at the initial execution. Advanced variable patterns. So here you can see for conditional logic we have used a variable instead of going with nested logic, which where the variable improves the performance. And second is this top 10 measure. Usually we will use rank x, but rank is iterated function. The same output can be achieved, but it increases the time and the suffix of performance. So this the same function can be achieved by this top one. So that's where we opted to use, we need to use a topper wherever possible instead of rank x. So I summarize the points for the variables. Uh, so open inefficient measure and task editor, so some appearing twice. So these activities which I showed you earlier, the tax editor. So your Power BI performance automation checklist. So these are things we need to take care of before doing a model design or creating a DAX measure or creating relationships. When it comes to model design, this is not compromising things. This we need to take care with serious attention. For example, star schema, remove missed columns, integer for IDs, disable auto date time, and filter source at rows at source, not in tags. And relationship visuals, as we have seen earlier, the default relationship should be single directional and the bidirectional should be avoided. And performance analyzer on every page you need to run to check the performance. Limit visuals per page. Yeah, optimum amount of visuals needs to be used. If it delivers the message clearly, then only we need to use the visual. We should not dump the report page with the visuals and use cross-filter for specific measure. This comes with bi-directional relationships wherever we need the relationship between two tables more than one, then we need to use this cross-filter. Then tax measures. Variable needs to use for any expression more than once in the measure. So to avoid again and again execution of the expression inside a measure. And use the delay for save division. So instead of direct division where it will throw error if 0 comes and the denominator is, avoid that we should use a divide. And calculator and filter or filter iterated function. Since filters and iterated function row by row is execution will happen, which increases increases the time and also affects the performance. So for in that case we need to use calculate plus implicit filter if possible. And we need to measure test measures with performance analyzers for tax measures also. And we can use return keyword for a debugging intermediate results. So these are the key takeaways which we have seen in this session. Performance starts in the model, not the measure and not the visual. Vertipack allows integer star schema load coordinating columns. So how Vertipack engine works? If you understand that, then we can design our model and we can create the measures in efficient way. Performance analyzer we need to utilize to identify the bottlenecks and boosts the performance of the report. Yeah, wherever possible we need to use the variables in creating tax measures. Yeah, measure, optimize, measure. Okay, never guess about performance. This is the important tagline which we need to consider. Then, thank you. This is from my end.